Before we can learn about stoichiometry, we need to know the definition. Stoichiometry is the calculation of reactants and products in a chemical reaction. If you look at this equation, we have the equation to make ammonia. So in this equation, you see here we have N2, which is nitrogen, plus 3H2, which is hydrogen gas. The arrow says it produces, which is also called a yield arrow, and it yields 2 NH3 or 2 moles of NH3, which is known as ammonia. So this is the equation to make ammonia. The reactants in this reaction are on the left side of the arrow. So it's going to be N2 and 3H2. Those are the reactants. Okay. On the right side of the arrow are the products. In this case, the product is just one product, ammonia. So here we have our equation again with the reactants and products shown above each substance. What the equation is telling us when you look at it is that we have 1 mole of N2. There's usually a 1 that we don't write when it's just one of them. It reacts with 3 moles of H2 and it produces 2 moles of NH3. So the ratio of N2 to H2 is 1 to 3. The ratio of N2 to ammonia, NH3, is 1 to 2. The ratio of hydrogen to ammonia is 3 to 2. So you can tell the ratios that you need to do the math from the coefficients in the equation. And this is why we have to balance equations before we can do this. So a good starting question and a pretty common question for stoichiometry is shown here. It says how many moles of ammonia, which is NH3, can be produced if we start with 4 moles of N2. So to do a problem like this, we have to use dimensional analysis, which your teacher may have taught you already, hopefully, if you've done the mole. So just like we use conversions for the mole, we can also use conversions like this for stoichiometry. So the given amount, which is 4 moles of N2, will have to go in the top left. So we place that in the top left of our dimensional analysis setup, 4 moles of N2. Now, the next step, once you put your given amount in, the next thing to do is to put the ratio that we talked about from the equation into this setup. So at the bottom of there, we need to cancel out moles of N2. And if I look up in the equation, it says that there are 2 moles of NH3 and 1 mole of N2. So what has to happen here is that we have to type in 1 mole at the bottom. So we're going to put that in here, 1 mole of N2. And again, that's to get everything to cancel out that we need to cancel in the equation. So that's in there now. The next thing we do is put what we want in the top right corner. So we're going to place that into the top right. So in the equation, we have 2 moles of ammonia, as shown right here. And we need to put in that into here. So we're going to put 2 moles NH3 and type that in. Now we've got our setup. And if we take and multiply the top 2 numbers, which we have to do when we're doing dimensional analysis, it's going to be this 4 moles of N2 times 2 moles of NH3. It's divided by 1 mole of N2, but remember when we do that, we don't usually divide by 1. It's a waste of time. You don't want to waste your time in chemistry. You want to get that as fast as possible and be right. So it's 4 times 2, which you guys can probably hopefully do without a calculator, and you're going to get 8 moles of NH3, which I'm trying to write with a mouse here, which is really stupid. So we end up with that. So NH3. Okay, now I switched over to the stylus and it still looks horrible. So my handwriting's bad. But anyway, you get 8 moles of NH3. So that's what we call a one-step problem. So what do we mean by one step? And that's where we're going to come in with a couple of hints and tricks here. If the question starts off in moles, like our last question said, you have 4 moles of nitrogen and 2. If you're starting with moles and it's asking you for moles, so if you're going from moles to moles, in a question in stoichiometry, that's considered one step. If a question has you starting in moles and going to any other unit, like going to grams, for instance, you're looking at a 2-step problem in that case. If you have a question that's going from grams to grams, that is going to be what we call a 3-step problem. And that could be grams to grams, liters to liters, molecules to molecules. It really depends on the question. But if you see mole to mole, it's one step. Again, mole to mole, one step. Moles to grams or grams to moles. It can go either way, 2 steps. And grams to grams or grams to liters or liters to liters, molecules to grams, any of those would be 3 steps. And that's all you're looking at. You have 3-step possibilities. 3 being the toughest, but it's really not that hard once you get used to the flow of the problem. So this is a pretty typical 3-step problem. And let me again explain how you would know it's 3 steps here. Couple of things that I see. I see grams shown here, and it's asking how many grams of aluminum are needed to produce 40 grams of copper. So remember, grams to grams is a 3-step problem. So let's set it up and show you how to do these, and I'm going to give you some steps along the way. So the first thing I do is put the given amount in the top left, and the given amount is the only thing numbers wise with units that you're going to see. And so in our question, it says you have 40 grams of copper. That's the given amount. That goes in the top left here. Okay, so that's first thing. Step 1 in stoichiometry, once you get it set up with your 40 grams in this case, the first step is to get it into moles. But I usually just tell my students get moles. So that 40 grams needs to get converted. So how do we get moles? Well, the first thing I do is I get out my best friend in chemistry, and that is a periodic table. And if you look up the mass of copper on the periodic table, it rounds to 63.5 if you go to the nearest tenth. And that is how much 1 mole of copper weighs. So that goes on the bottom. And again, when you do that, you can get things to cancel out. So grams of copper will cancel out with grams of copper there. Now, on the top of that first ratio that I'm putting in, I put 1 mole because the first step, again, is to get moles. So that is the first step taken care of. I got it to moles. Well, the next thing to do is going to be what we call step 2 in stoichiometry. In that step, step 2 is really important, and it's why we have to have a balanced equation to do that. The second step is to use the equation ratios. And so when you look at the equation, we're only concerned about 2 things in this reaction. We want to know about aluminum and we want to know about copper. And the 2 numbers in that equation that relate to aluminum and copper are a 2 and a 3. So in the bottom of the next ratio setup for dimensional analysis, you're going to notice that I typed in 3 moles of copper. Where's the 3 coming from? The 3 is coming from the equation. And up in the equation, we have 3 moles of copper. So that goes down there. Now, the question is, why does it go on the bottom? And again, the reason for all of this setup is to get things to cancel out because we're eventually trying to get it to grams of aluminum. So that's going to cancel out moles of copper. That's going to cancel out. moles of copper. So if you see it diagonally like this, and it's set up in that way, you can cancel it out and get rid of it. And what we're really trying to do is move on to the next step. And the next step is step 3. But we're not to step 3 yet. First, we have to finish up step 2, which is to use the equation. Now you notice the top is now in there, which we have here, and it says 2 moles of aluminum. Again, the 2 is coming from the equation up here, 2 moles of aluminum. So step 2 is complete, and we can now move on to step 3, which is really the final step of this process before you start into a calculator. For step 3, I really keep these steps simple so you can remember them. And step 3 is to get what you want. What we want out of this whole process, besides getting the answer right, because you'll get points on a test or a quiz or in your homework, but really we want to get grams of aluminum when it's all said and done. And so whatever we do, we've got to end up with grams of aluminum in that top right. We started off here with 40 grams of copper. We took a little journey, got moles, used the equation. Now we get what we want in this third step. And if you have that set up right, in my class, you get credit for each little part that you put in. And this question has 1 point for the 40 grams, 1 point to put that in correctly, 1 point there, there, and there. You're looking at an 8-point problem. Even if you don't know how to use a calculator, which, by the way, is a horrible reason to miss a problem, you're still going to get 7 out of 8 points in a question like this in my particular chemistry classes. So having it set up right is really the important part. The right answer is great, and it gets you that final last point. But if you can set these up, you're showing you understand how to cancel units, how to get the answer for this, and then it just becomes an issue of, can you put it in a calculator correctly? Now, you're going to notice I put 1 mole of aluminum on the bottom. So we're trying to get moles of aluminum to cancel out, which they do because I've got them there and I've got them there. The reason why it's a 1 there and not a 2 is because I just want to know how much 1 mole of aluminum weighs. The 2 will take care of any doubling that has to happen, the 2 that's over there. So in the top right over here, we need to put how much aluminum weighs. And guess where we're going to go? We go to our best friend in chemistry, the periodic table. So I look it up on the periodic table and I see it's about 27 grams. It's like 26.98. And, for now, I go to the nearest tenth, and that's good enough for what we're doing. So now we have the correct setup. Everything's canceled out. What I'm trying to get is in the top right here, grams of aluminum. And so I've got a perfectly set up problem. Then it just becomes a matter of plugging it into the calculator. So to do this, I start off with 40. I multiply by 1. Again, I don't put ones in the calculator. It's a waste of time when you're multiplying. Then I go times 2, then times 27. And then I start hitting divide. So I'll hit divide 63.5. I do not hit equal yet. I hit divide again, and I plug in 3. If this isn't a 1, but it will be, I would hit divide 1. But again, do not divide by 1 or multiply by 1. It's a waste of your life. Then I hit the equal sign at the very end, and I'm going to get my answer. So try to plug that into a calculator the way that I explained it and see what you get. I got 11.3 grams of aluminum, which is the correct answer in that case. So this is what we're saying here. If you take aluminum, you put it in copper chloride solution dissolved in water. If I put 11.3 grams of aluminum into that solution of copper chloride, CuCl2, I will get 40 grams of copper. Theoretically speaking, now that's a topic for another time, but it's how much we could get as long as everything went perfectly. So this is how we set up a 3-step problem. And again, it's 3 steps because I'm going from grams to grams in this question. If I started off with moles of copper, I'd be on the first step already here. Then I would go there and then there. So you can see that it's 2 steps if I start with moles, going to use the equation and then get what you want. If the question started in grams and went 2 moles, first step, get moles. Second step, use the equation, and I would end up in moles of aluminum. So you can tell in a gram to gram that it's got to be 3 steps to get you there. And if you follow that, you'll get them right every time.